benchmarks are well known that the cruise sector now leads the LNG supply design of the design of LNG supply fuel vessels. We have some huge cruise vessels under design at the moment from Carnival and MSC. But also we have novel examples of smaller vessels in the RoPax region, in the cargo region, and even in the tug cluster. You may identify in the middle an escort tug built in Spain last summer, powered by LNG. This is a very good and very interesting example of a small ship powered by LNG. This is the iconic Viking Grace, the pioneer vessel of the LNG era. Everybody knows it. And those are some examples of recent delivered vessels. Salis Orca is the latest of these, delivered 2 months ago to BC Ferries in Vancouver, Canada. Apart from new builds, we have also to consider conversions. The conversion might be a good option for the ship owner, but might not. So, before moving to conversion, a ship owner must examine some factors. First of all, a conversion might be technically more demanding and more difficult as a challenge than the new build. The age factor is the most critical factor for deciding to go to the retrofit or not. As a rule of thumb, we have concluded that a vessel of around 2 years, 20 years old or more should, in general, be not preferable for conversion because the financing future of the vessel is limited. CAPEX and OPEX calculations must be extremely accurate in order for the decision to be made. And of course, the shipping company must take into account some side effects that will occur within the operations pattern. As an example, I wrote here the need to update port operating procedures, company's ISM, introduction of dedicated LNG training for personnel onshore and offshore as well. So the conversion decision must be very carefully decided upon discussing those figures. The bunkering procedures, which is also very important for the LNG fueled vessels, has also been transformed from the early 20s, from the early zeros, where the capacities were very small, 100 to 100 cubic meters, typically by truck. We are now moving to ship and amounts between 2 and 4,000 cubic meters, and in the future, in the very near future, more than 6,000 cubic meters per hour. A very delicate case should be the SIMOPS, the simultaneously operations. This is something that must be very carefully drawn and taken into account when we are about to bunker LNG fueled vessels, especially passenger ones. SIMOPS should be allowed in every case, provided that the operator is demonstrating a very robust mitigating measures practice. And this is very effective and also authorized by the authorities and the port where the vessel will be bunkered. Going to Poseidon Med 2 design work. Within the last 2 years, we have started our design obligation work within the program, and this is split to the retrofit design and the new builds design. For the retrofit design, as most of you know, we have the obligation to study 10 candidate vessels selected by Poseidon Med, by Archipelago, and we have also some new entries, new selections for Poseidon Med 2 program. And the design process covers both the basic design for 5 vessels and the detailed design for the other 5 batch of vessels. By defining basic and detailed design, we are referring to the detail of the LNG system on board and on the parts of the vessel affected by this installation. The basic design cluster includes 5 vessels, namely Terrajet, Panvision, Apiliotis, Hellenic Spirit, and Nissos Mykonos. While the detailed design batch includes the Festos Pallas, which is our case study vessel, super fast one, high-speed 6, Neptune Galini and Amochostos, which is similar to the new build tag addressed earlier. This work now is in progress, and the deliverables will be submitted formally to the program by June 2018, the basic design, and by June 2019, the detailed design. Apart from the retrofits, we are now moving, we have concluded actually, our new builds design. And the new builds design included the concept design of a conventional LNG fueled vessel for short sea shuttle service, and the detailed design of an innovative RoPax ferry. The deliverable has already been forwarded to our consortium for final approval, and it will be ready for official submission within the next days. We are proud to present to you our innovative compact RoPax ferry design, which is a completely new breed of compact RoPax ferry, designed by ship owner Blue Star Ferries. Blue Star Ferries is also partner to the program, and followed by incorporation of safe return to port obligations and compliance rules with SOLAS and Stockholm Agreement, and all this work has been done by NAP Engineering, another partner. LNG, which we studied the LNG system on board, and the whole package was being reviewed by Lloyd's Register and is ready for a nomination of approval in principle. This design has some innovative factors. Of course, we have almost no emissions due to LNG. We have optimized the hull form by reducing 10% the hull drag as a result. And we will apply some novel operating systems, for example, using of water for consumption on board and electricity in order to minimize the environmental footprint. On top of that, the vessel will be ready for cold ironing future installation in case the ports will support this facility. Another chapter on the design work was the LNG bunker feeder vessels. We have finalized this work in previous March, and the result are two bunker vessels which are tailor-made for the region and which include the minimum performance requirements as identified in my slide. We are talking about the first vessel we're talking about is Amalthea 1. It's a small bunker vessel scheduled for transferring LNG between Revithousa and Piraeus port. You can see the main particulars on the table. This vessel has the particular high-speed value of 14 knots in order to gain time shuttling between Revithousa and Piraeus. The second vessel is the Amalthea 7000, which is our feeder vessel, specifically designed for the role to supply LNG to ports and land infrastructures, mainly, for example, Patras, a new LNG terminal. But it's not limited to these roles. It can bunker larger vessels as well. This vessel has been designed with two options on tank configuration. We have included membrane tanks with a capacity of around 7,000 cubic meters, but also we have designed the vessel with Type C below tanks, but the capacity is limited to around 5,000 cubic meters. Those two designs have also been reviewed by Lloyd's Register within the frame of the program. The shipyard preparedness is our last chapter in my presentation. It's very important, and again it is within the frame of Poseidon Med. Our obligation was to identify shipyards around Attica and around Greece as well for proper evaluation in order to transit to the LNG era. The task is to identify critical factors that the Greek shipyards are facing right now, and to highlight problems, to highlight showstoppers, but on top of that also to draft some kind of solutions. The aim is to prepare a list of shipyards that they will be capable not only for retrofits but also for new builds, even if the LNG system will be supplied by technically experts from abroad. As my last slide comes on, I would like to focus on the successful Kochi shipyard case. Kochi shipyard is located in India, and last year was assessed and approved as fit to design and build small-scale LNG carriers, and this was done in coordination with Engineers India. All of this action was under the umbrella of the Indian government. And I would like to stress out, and this might be also food for thought during our discussion, that the shipyards, in order to be ready for the transition, must be also supported by the public sector and the private sector as well. So, thank you very much for your attention. So, moving on to our presentations, I would like to invite Mr. Sergei Poprakko, who is the Managing Director of ESIF Management Services, member of the Executive Board of PAO Softcomfort Float.
Good afternoon. So I will represent the ship owners and the ship operators' point of view on the LNG as a fuel, and how we're going to proceed with this in light of, shall I click myself to move slides? Or? How to? Oh, all right. Yeah, and how we are going to meet challenges imposed by the decision of IMO on the sulfur cap starting from January 1st, 2020. Many experts say that most probably the demand for the low sulfur marine gas oil will grow so significantly that existing refineries would not be able to provide enough bunker for the existing and future fleet to comply with the IMO requirements. So alternatives were offered, like switch to LNG fuel or install scrubbers. Our choice was, anyway, switch to alternative fuels as natural gas, LNG, and we just, in March 2017, this year, ordered 4 Aframax vessels with extended cubic capacity that weighed 114,000. They are going to be first ever vessels of this type fueled with LNG. In the previous presentation, you saw pictures of vessels of different types, smaller, bigger, cruise liners, but that would be unique vessels, specifically built for the ice trade. Vessels would be start delivering later this year or next year. And we believe these vessels would be fully compliant with all the challenges we, as ship owners and ship operators, going to meet from January 1st, 2020. In order to switch to the LNG as a fuel, some important considerations were taken into account by regulatory bodies like US Coast Guard, classification societies, and they actually formed like which already, I mean, these specific conditions were already addressed in the previous presentation. So basically we're talking about things we have to comply before we and decide for ourselves before we order the vessels of this by specific type. So again, we're addressing vessel design, her performance, operations, where going vessel to be operated, maintenance, infrastructure, if bunkering infrastructure available, of course, CapEx, safety issues, already previous colleague mentioned already in his presentation, and of course crew training. How are we going to approach this specifically in Sovcomflot Group? And we agreed with the shipyard on specific design and with the main engine maker, which is WinGD, quite famous and well-known organization. That would be low-pressure engine, able to deliver power more than 13,000 kilowatt, and can be both operated in either fuel oil or LNG. These vessels are going to be operated in ice conditions, as I said, primarily in the Baltic and North Sea, and we're going to be involved in Russian oil export from the Baltic terminals to Europe. Sometimes, of course, they might be involved in cross-Atlantic trade. Talking about operations, we believe that the area where vessels are going to be traded, north of Europe, quite convenient location with regards to the availability of repair facilities, maintenance facilities. I believe it's not a big deal. We have quite famous and known shipyards, suppliers, makers, whatever, and whoever available in this specific area. Talking about CapEx, which is important thing, vessels of this type are more expensive than conventional vessel. Of course, they're also conventional vessels, but what we call conventional vessels which would not be able to operate with dual fuel. CapEx slightly higher, but more than 10 million per vessel. We believe that getting into specific agreement with one of the major LNG players in the world, like Shell, and having a big deal with them, like to supply natural gas as a fuel to our vessels, specifically around Antwerp area and in the Baltic, would help us to offset higher OPEX, because we could enjoy specific oil price, specific LNG price, which set in such. Talking about safety, we work closely with Shell in developing manuals, procedures, checklists, because nobody before did the same. We work with the terminals specifically to enable vessels simultaneously perform cargo operations and deliver LNG bunker. Shell actually formed a working group where different ship owners who really want to build vessels and operate these vessels with their vessels with LNG work closely with Shell really to develop safety guidelines to make these operations really safe. And accordingly, our safety manuals, our SMS amended to meet all these challenges and facilitate our operators, our superintendents, our crew, with comprehensive procedures on how we're going to proceed with bunkering of these vessels, with LNG. As for the operator training, since 2006, we have been operating LNG vessels. We accumulated a great deal of experience in managing LNG vessels, and specifically vessels with dual fuel, diesel electric. Of course, these vessels equipped with different type of engines, say medium and high speed. That vessels we built for Shell contract would be operated with slow speed engines, but anyway, initial experience already there. Those who live in Cyprus perhaps remember, like 10 years ago, first BP LNG carriers with dual fuel engines were sitting here idle, suffering from some troubles with machinery equipment. At that time, really, nobody had experience in operating these vessels. Even makers could not produce reliable machinery. But now I think all the experience there. And we have quite good, big experience crew pool, who of course then would be employed on our vessels to operate unique machinery. Furthermore, we work closely with the makers, and the additional training would be provided at the makers' facilities. Besides, we have our own in-house training facilities where we really can train our crew. And here you see the pictures of our vessels, which dual fuel, diesel electric. Of course, they are all gas carriers, but as I said, it could be a good training school for our crew for future LNG fueled Aframaxes. And in conclusion, if we believe that our experience in building this and operating and building LNG fueled vessels can be taken as an example, I don't think so, because in any particular case, each ship owner has to decide which way to go. And there was a recent article in the Financial Times where they published a research made by the Swiss bank UBS, which shows that majority of ship owners really hesitant to switch to LNG. They still prefer to stay with the low sulfur fuel. It's because they're really concerned of capex and infrastructure. But things moving on, and we believe that it was already mentioned here that pretty soon we will see more bunkering budgets, infrastructure would be developed, and probably higher capex would be then offset with the availability of cheaper bunkering. So in conclusion, as I said, a lot of uncertainties what this 2020 CAP will bring to us, and at the end, as usual, money talks, and decision would be entirely specific, individual by different ship owners. But as I said, we made our choice based on the specific study we made, and at the end we're going to have these 4 LNG vessels delivered, 4 LNG fuel vessels delivered pretty soon. And we will share then with you, probably at next conference, how we're going, our first experience with this vessel. Thank you very much for your kind attention.
Thank you very much, Mr. Popravko. I would like now to invite Ms. Maria Kiratsoudi, Regional FOBAS Business Development Manager, South Europe, Marine and Offshore of Lloyd's Register, for her presentation.
Good afternoon, ladies and gentlemen. I would like to thank all of you for your presence here, as well as the organizers for the invitation. During the presentation, we are going to discuss about the quality and the quantity verification processes and procedures using LNG as a fuel during bunkering. In order to be able to decide and create this process and procedure for measuring the quality and the quantity for the LNG as a fuel, we have to consult it, first of all, what currently is happening at the LNG as a cargo industry. We have GIGNL that provides a lot of information with respect to how it should be treated, the quality and the quantity. So we have found a very, very good source of providing us input in our study. The other thing that we have done is that we have checked whether the practices from the traditional fuel oils can be applicable in the LNG bunkering industry. And I would say that bottom line, very few of them can be applicable because the philosophy is totally different, having the traditional fossil fuel oils and the LNG as a fuel. Also, we have conducted an evaporation study in order to see how much the quantity is being reduced. And of course, finally, we have taken into consideration all the previous studies that have been delivered through various activities of Poseidon method too. Few things about the quality. The fuel oil quality and the LNG quality are totally different things. When we say fuel oil quality, practically we mean the concentration of some key parameters. How much is the viscosity? What about the density or the cut fines? We expect that there will be a level of contamination, and this is where ISO comes and says to us that the expected level of contamination is described in some tables. Whereas for the LNG as a fuel, we don't have this type of contamination because any contamination is removed by liquefaction process. So practically, when we say quality for the LNG as a fuel, we mean actually the natural composition, the percentage of the methane, the ethane, the propane, the key characteristics. Another key thing that we need to stress is that for fossil fuel oils, in case that the fuel is off spec, the quality is not good, this might be a safety issue. For example, when you have a fuel oil that the flash point is below 60 degrees, this is considered by MARPOL, of course, by SOLAS, a safety issue. Where in LNG as a fuel, this variability in methane number, which might cause probably low quality or a little bit of low quality of LNG as a fuel, this is not concerned as a safety issue. For LNG as a fuel, though we don't have an ISO that describes the quality, and I don't believe, honestly, how easy it is to have an ISO that it will describe actually the composition of LNG. And the reason it is because there are a lot of the LNG composition varies globally. As you can see also in the map, the composition of LNG varies with different suppliers, different sources, different production facilities and supply chains. So, what is the solution in these things? You can see, for example, that Europe most probably will import different qualities of LNG composition. What do we do in case like this? The solution is very simple. It is forward planning. We need to take into consideration, first of all, the availability of the ports where we go, and also we need to take into consideration the ability of our machinery to use this type of LNG composition based on the trading area. One more thing that we need to consider is, of course, the contractual arrangements. We need to have proper contractual arrangements in place before the arrival of the vessel at the port. Now, with respect to the quantity, the solution we have decided to propose at the milestone 16 is pretty straightforward. It is tried, tested, certified, approved, and most probably globally accepted by the LNG industry, and it is what it is described as the GIGNL handbook, volumetric measurement, simply as that. We have thought also whether we can try to use the mass flow meters for measuring the LNG as a fuel. However, we need to consider that mass flow meters very much recently marinized, and when I say marinized, I mean that they have started being used in Singapore from 1st of January, compulsory for the fossil fuel oils. So for the traditional fuel oil. So we understand that, especially for the LNG as a fuel, we need to develop standards, procedures, and certification, and we need to have this method that it will be equivalent robust, like it is the method of volumetric measurement that it is described at the GIGNL. One more thing that we need to consider is that if we focus very much on the energy content, which is highly possible because with mass flow meter you avoid calculating, for example, the density and the viscosity, you go directly to the mass. And in that way you simplify the calculation of the quantity. It is highly possible that we could result in increased cost as we used fuels with LNG fuels with lower methane number. Our technical investigation department based in Southampton, we have decided along with them to conduct an evaporation study of the LNG quantity. We have made some assumptions. Some of the key assumptions that we have made is that first of all that the tank does not have a pressure or mass flow inlet or outlet, so we don't expect any boil of gas outflow. And there is no preferential evaporation of species from the LNG. You understand most probably that these are not totally identical, and this is how it is on the reality. However, we need to make some assumptions. Some other assumption it is that the ambient temperature is around 33 degrees of Celsius, and the initial conditions in tanks is 0.25 bar and 111 Kelvin. Based on these assumptions, we have proceeded with the modeling. Well, the mass fraction, as you can see also, it is the methane number is less than 95%, the ethane content is approximately 5%, and the propane is around 0.1%. This is the LNG species proportion as used, and we have decided to fill the 65% of the tank. One thing that we need to say is that the temperature has been modeled and it is dependent only on the thermal insulation. The result of the evaporation study showed to us that 0.1% of the total mass has been evaporated before the saturation point is reached, and the pressure in the tank reached approximately 0.7 bar at the saturation point. Actually, the second one has been also reconfirmed by the other studies that they have been conducted through Poseidon MED activities. Well, now more things on the milestone 16 on the report. We have 6 routes as it is as per Poseidon MED 2. We start from the key terminal, which is the terminal of Revithousa, and then we have from terminal Revithousa, we expect the supply chain route to go to, of course, Iraklion, Igoumenitsa, Piraeus, and Limassol. We have also one more future small-scale terminal, which is based in Patras, and then we expect the fuel to be delivered, the LNG to be delivered from Revithousa again to the Patras terminal, and from Patras terminal to the Igoumenitsa port. Based on these 6 supply chain routes, and considering also various types of operation, because it's not only one, it has already been described, we have bunker vessels that they have also type C tanks, bunker tanks. It is expected that we might see also trucks, so because of the small scale. So we have terminal to bunker vessel, ship to ship, terminal to truck, and truck to ship. All of these operations, along with the 6 supply chain routes before, they have led us to create some flowcharts. I have decided to present you 2 of them. The first one is from the terminal to the ship, where the LNG goes from the terminal to the ship. It is with the barge or the feeder where we have their type C tanks. As I say, this is a closed system, so it is expected that the quality will not change. When we say quality, we mean practically the density and the gross calorific value. So we allow the terminal to define how much the density and the gross calorific value. And finally, what the ship gets is practically the volume, which has been measured again in the terminal, times the density, times the gross calorific value, minus any energy that it has been consumed while the barge was using LNG as a fuel. The second flow chart that we are presenting here has to do, it's approximately the same, but in the middle you can see that we have the feeder with the membrane tanks. So it is expected that we might see a little bit of change at the quality of the LNG, and I say a little bit of change. We expect, though, to see some difference on the density of the gross calorific value, not that much significant, though, because the volume is around 7,000 cubic meter, and the maximum days of operation is about 7, so we don't expect that we're going to see a lot of change. However, we have suggested to have on board the ship a GC analyzer in order to confirm again the density and the gross calorific value. I know that having on board the ship a GC analyzer is not identical, because from my experience also in the traditional bunker fuel oil industry, it's not an easy equipment. However, there are more simplified equipment for this analysis. So practically the energy that it is received from the terminal to the ship, it is the volume times the density times the gross calorific value, how they have been determined by the GC analyzer on board the ship, minus any energy that it might be has been consumed during any operations. Except for the flowcharts and the procedures that I have already said that are covering various scenarios and bunkering operations, inside the report you might find also the energy transfer determination sheet, certificate of quality, and a proposed bunker delivery note. These are the documents that, especially in the first flowchart here, for example, that these documents will go directly from the terminal to the ship. So we don't expect any significant involvement in the middle, which is something totally different which is happening currently with the traditional bunker fuel oil. In the traditional bunker fuel oil, there is a lot of manipulation with respect to the fuel. You know also possibly malpractices that might be happening in Singapore or in other areas, where in LNG, due to the nature of the LNG, it's not that easy to be done. So it is practically the responsibility goes back to the terminal, and the documents given by the terminal are the ones that they are valid. This report, I would like to say, concluding that this report, it's not, it is a dynamic process, and it is expected that most probably it might be changed, taking into consideration other activities that they might come, as well as any industry developments. Thank you very much.
Thank you, Mrs. Kiratsoudi. I would like now to invite Mr. Marinos Polatos, who is the technical manager of Navep shipyard in Piraeus, Athens.
Good afternoon, ladies and gentlemen. We heard. Sorry, this is not. During the last few hours, we have been, all of us here, wiser, and really we heard very, very interesting things about this the subject which are all involved. However, this chain, starting from the chemist going to the designs, etc., to be closed, somebody we understand that has to do the dirty job, meaning somebody has to build the ships. That's why I'm in front of you. I have changed for one day my dirty working overall, and I'm in this nice suit to present to you not only our, but also several other colleague shipyards positions and point of view facing this total new challenge. I have two sectors to highlight. First of all is the necessity why we consider that new yards should enter in LNG business. Secondly, there's a brief approach to some prerequisites allowing the traditional old steel yard to undertake LNG projects. Okay, so this is our nice yard in Salamis Island. It's a fact that since the last decade, the environmental community started to enter the safe, clean and environmental era of LNG, both as household and industrial fuel, but also lately as progressively as a shipping bunker. Directly connected here too was the rapid increase of the demand of the LNG carriers, which presently undertake more than 75% of the world's gas transport. Exactly, that was my topic only a few weeks back in a roundtable in a conference room of the old traditional Blumenfos shipyard in Germany, where I had the chance to participate in a discussion, especially with old and multi-experienced colleagues, which addressed that we should be in the same crossroad like exactly a century before, back. On the decade 1910 to 1920, where the oil started its frightening appearance as the new, at that time, revolutionary bunker with so many opponents at that time towards the coal. We are at the same point. The difference of the two shipbuilding eras is just the shipping target. 1 century back, the size and the performance speed was the primary scope, whereas today, the environmental sensibility combined with the economy will for sure dominate the forthcoming decades. Unfortunately, we should suffer first some Exxon Valdez, some Ericas and Breas, many of you, especially old colleagues, know and remember, to sensitize the world's community feeling regarding fuels and energy sources. Sorry, yeah. I have disclosed for you will be uploaded in the web the present already set LNG new building orders and retrofits, which should be handed over, are already handed over from 2016 until 2022. For all of us, these are existing more than all in all 170 to 180 vessels. And what I'm presenting to you right now was the distribution of new buildings only back to 2014, meaning that 9 yards worldwide at that time were dealing with the LNG new builds, which for us it's something which is not acceptable as small, medium yards, and at the same time that the demand is increasing and the tendency is always going to this new technology. These are actually 2014, 2015, the companies order this, put these new yards, ordering the new builds on the new yards. Okay. So, taking into account that these will be until 2020 the new land-based facilities worldwide, there will be for sure an additional demand for tonnage to come of at least, experts assume 50 to 60 vessels to be placed as an order recently in the next 1.5 years approximately. On top of that, only a week ago, South Korea Ministry has announced a pilot program to build the world's largest LNG powered vessel of 180 gross tonnage, which the size of which about 1 year or 1.5 years would be unthinkable for all of us. Okay. In spite of the new service or cargo vessels, cruise industry is taking a huge participation on the new technology, with having the first vessel Ida Prima, which is, I don't know, Yanni, if your information or my information is more correct, but either way, they already started to enter this the LNG dual fuel since 2011. On the other hand, very recently also Disney Cruise Line followed the international cruise trend has ordered 3 LNG-powered cruises at Megerwerft, Germany, which will be delivered between 2021 and 2023. And recently, we saw advertisement of operators like Carnival and TUI, which are advertising in advance clean relaxation in world's most untouched and virgin locations. Okay. And we saw also innovating designs for conversions of existing cruises sorry, jumped. Can we go one back? Okay. Of design offices which with concept of prefabricated LNG tanks, which which are in contact with already big yards in Europe and Far East for the implementation of LNG dual fuel. Okay. So now yards, new yards which have dealt previously with steel vessels, wishing to undertake LNG project. They have to introduce some key points in order to be able to undertake contracts. First of all, the covered or partly covered building areas, new enclosed or at least partially covered slipways or docks. For these high demanded new buildings is strongly recommended, at least on several sections, to avoid open air construction. The covered advantage increases the productivity by far, and it's offering many plus points, especially on summary orders. Eliminate excuses for us, for our owners, for delays due to weather condition, protects sensible equipment, increasing productivity to at least 35 to 40%, as it's been also discussed in Germany last few years back. We have to invest in new welding technologies, and where serious investments in high-tech welding technologies, both in modern required equipment as well as welders' education, and continuous practice on inox and bimetallic materials widely used on LNG new buildings and retrofits. Further on, the pipe construction totally differ and varies from the traditional bunkering, the traditional ballast or bunkering piping. It is costly and essential, otherwise yards will not be able to undertake nowadays LNG new builds, for sure. We have to invest in in-yard simulation of LNG storage facilities in order to process a complete loading and discharging sequence prior vessels delivery. We are not constructing any more bulkers or tankers. We have to prove, and we have to be sure, delivering an LNG vessel, that the loading and discharging sequence or the bunkering sequence in case of retrofit in bunker will be for sure completely assured. The mentality of safety of our workers is one major topic. It's a very, very important issue. It's not anymore dealing with bulk carrier as a double bottom, but is dealing with high flammable materials explosive materials in some cases, and we have to be very, very careful with this, and invest also in safety material as well. And most of all, in order a yard to appear competitive in the LNG new building market, has to offer reasonable deliverable packages, including designs, engineering, and supervision for building of the LNG units. The last chapter, which I'm mentioning now, requires increased high-tech human in-house education skills, of which the daily presence on the ongoing projects is essential for the correct fulfilling of LNG, of new buildings or conversions. So, entering the last section, you allow me please to concentrate and give an emphasis to a few active Greek yards which are able to fulfill the above stated technical prerequisites. We have not started at the moment, but we are here and willing to come in contact with owners, with operators. These yards, like LFC's yards here, as you see, like Neorion yards in Greece, have for sure the adequate knowledge and experience, both in design, but also in engineering and production, and are willing to undertake LNG projects related either to retrofits or even to new buildings. Yards like this and a great number of other middle-sized productive yards is really pity to remain out of the active worldwide and fair competition, at the same time that the major client, one of the most major clients to the famous Far East yards are Greek shipping companies. Okay. It's a honor for me to announce that our yard, Navep in Salamis Island, is the first one being examined and preliminary approved by Poseidon Med2 program. Thus, we are proud to declare to the present community that we are here, offering in Greece and in Cyprus our expertise in LNG retrofits and new buildings, especially having lately fulfilled in Greece the two biggest conversions and repair projects, the Industrial Jazz and the famous Qatari yacht Al Mirkab. We, along with all Greek yards, are asking for your support, namely the support of ship owners, designers, classification societies, and most of all from all bank financing institutions, if some of them are in this room. It is pity foreign yards during discussions with owners to appear on the same table with bankiers before their technical managers, and in Greece to be total absent from any shipping project. We don't want to face pictures like, can I have the previous picture, please? Okay, we don't want to face picture like this, which is the number 4 dock in 4,000 deadweight in Hellenic shipyards anymore in the future. We are here, we have the will and the way, we can deliver, try us, and in good faith, miracles which can speak the same language might happen. Okay, thank you very much for your attention.
Thank you, Mr. Polatos. Our next speaker is Mr. Abdullah Diouf, Market Development Manager of LNG Process Operations, GTP France, who is going to present his speech.
Good afternoon. Good afternoon, everybody. It's a big challenge for me because everything has been pretty much said, right? So I'm trying to be a little bit more concise here, trying to go into the facts because we also have engaged ourselves in different pools of of understanding the challenges and diving into resolving them, right? So, of course, shipyards doing the dirty job. We're not going to call it a dirty job. It's the necessary job there. And so many people doing tremendous effort on the design phase. That's also a necessary thing. So what pops up here is the need for collaboration, of course. And I just realized that all the efforts which have been done here, we also somehow did them separately. And then, wow, why not, you know, joining efforts and doing everything together? But there are some works I would like to present to you, and also dive into the pillars for getting this LNG market reach an upper echelon of greater good, right? So very quickly, who we are. We are GTT. Maybe some of you here are familiar with the company. 400 LNG carriers are equipped with our system, so we equip them. That's a big pride. It's not only LNG carriers, but we also have in the pool FSRUs, FLNGs, you know, onshore tanks. Yeah, list goes on and on. So the challenge that we face here is that we have big experience with big LNG carriers. How are we gonna scale down this expertise into something very comprehensive? So we have identified basically different pillars we have to work on. So of course, yeah, hearing lights, that's definitely an expertise that we need, and they've done a tremendous job on it. But on the designer phase, we have a different attacking angle. Has it, has up, you know, those are something. But once I'm trying to project a picture here. If you look at this one right here, some people, you can have different feelings. Some of you can see some commercial opportunities. Some others could just see, you know, vessels sailing alongside the water. Some people would just say, well, if ever we have a LNG barge in this overall picture, I mean, that's collision risk here. That's safety risk here. So you guys, how are you going to address it? So that's one thing to define, of course, safety distances. And that's another thing to dig deeper into what it means for real. And the company that we do, what we did recently was that we say, well, okay, what to answer those guys who continuously question the safety system, safety of the containment system. So we work with a class there, and we created a artificial force in the middle of a membrane ship, and then the picture here was to see and understand to which point it could resist and from which point it will break. You see, so just imagine that there is a container vessel fitted with a containment system, sorry, and then you're gonna have a collision coming probably all the way around. Never hope so, but things like this have happened. So we just go to the lab and see what it does. And surprisingly, we have reached a rupture point of 8 meters, which means that to be able to break the containment system, the bulb has to enter up to 8 meters. So skeptical people who question, well, containment system with LNG, what it does, okay, we're gonna define some safety zones, but the result is very clear here, and that's what we're trying to do. In the company, we're trying to get into the details of, you know, this surface thing, and trying to give some analytical answers. So that's very encouraging to address this collision point, just to say, well, it doesn't really break easily. The second point here, the second pillar has a designer, is just to see to which point the transfer operations are under custody, because if we talk about a barge fueling a container ship, there's so many challenges. First of all, the fueling operation has to be performed in a not necessarily in a short duration, but in duration that doesn't compromise the overall staying of the container. There's time ups going on, simultaneous operations. There is no need for highlighting the fact that venting is not allowed at all, except in emergency situation. So reputation might take a hit right there. Owner might not really want to dig into the LNG thing for the next vessel. So we understand that ship-to-ship transfer custody is a must. So how does it differ, this picture from big scale? So small scale, we're going to have the scale impact, of course, equipment having lower capacities, the frequency impact, because we can have some kind of daily operation or hourly basis based on different vessels, of course, and all these safeties and SIMOPs. So what we did is that we did a big work on the lab, surrounding ourselves with people like Airbus, Iran Group, basically, to try to refine the models for evaporation, aging of LNG, and understanding how the transfer works. And then we advised actually NG Zeebrugge for the filling of their barge in Zeebrugge. So that's a big pride there. Supporting operation, I'm not gonna spend a lot of time in it. So we've seen that so many people invest on the training thing. So we also have our training course. Maybe a cooperation it can be shall be done right there. But what's good there is that there are different levels of training, and going from just getting you familiar with the basic principles towards making a software be available in-house for your operators to train themselves and basically do mistakes before getting on the real life where mistakes would not be necessarily tolerated. Yeah, so this thing right here is really important because we're talking about CAPEC thing, insurance. Some people really forget about the global picture of insurance. So the perception of insurance makers about LNG, what it is. So we're trying to actually put some, or at least define some critical scenarios and define basic procedures to say, well, everything is under custody. There is no concern whatsoever, provided that you follow these procedures, and these are not a rocket science thing. It's pretty much easy to handle and to implement. So we heard a lot about the CAPEX blockage at the initial phase for the owner. So the company I work for, we're trying to design the vessels in a way that it's kind of lean. So I don't like the word cheap because cheap is really cheap, and lean basically means that you've made a balance between the CAPEX and the OPEX, and this is kind of optimal solution. And this is a prerequisite for owner of the bunker vessels to get back on their feet, financially speaking. And at the end of the day, because of the cost of the vessel would be replicated on the cost of the fuel, the owner of the final customer, which is the LNG fuel vessel, container ship, ferry, will also get a cheap molecule. So we think that the design there shall be done in a way that we're not going to see, maybe there so many things have their reason to be, but flexibility at the initial phase because of uncertainties, that's something to maybe think about once again, because that's very good to have a very flexible vessel. But look at this picture right here. So I'm starting from a barge which is very local, which has minimum redundancy, which is very cheap, right? But because it's cheap, you're not going to be able to serve many customers. And going all the way up to something which is located to a port but can be redeployed to the next port, very high redundancies, can fuel a ferry, a cruise, a bulk carrier. It's okay flexibility wise, but is it good to go for it given the cost? And we think that the truth is between the two things. So there is an optimal solution somewhere around where you're going to have a good balance between the CAPEX and the OPEX. The right amount of money put on the table to serve a minimum number of customers and then get back to your feet. And then that's the pool on which we've been working for the last 2 years. And that's a big picture just to say that we work with ports and terminals, mostly in Europe, in Southeast Asia. The idea was there to do some compatibility studies, basically. We work with classes to validate some design characteristics and LNG suppliers just to see what are the constraints. Shipyard readiness, we just said it this morning, but that's the big thing to work on, because that's one of the key things people have identified, but very little. Yeah, thanks very much. But efforts need to be pushed to a next step. And that's where it goes: cooperation, collaboration, and working all together. Just a few words about our barge. We have a bunker barge in Mississippi River. This bunker barge right here will serve C-type tanks from Tote, which is a container vessel fitted with C-type. So it's filled with our technology, hopefully going to be commissioned next month. And this has been a very good learning pool, because it was at least it's a Jones Act vessel, unmanned vessel, with cryo coolers on the top, and basically because it's the first barge in the U.S., it was kind of like standard making for the U.S. Coast Guard and ABS. So they had to take the time and define very well the procedures, and this was a perfect pool for application, and say, well, this has to be done like this, like this. So work together. They challenge us a lot. The shipyard never made membrane before, so we managed to do it, and hopefully it will be commissioned next year. Where I'm coming from is that because of the lean concept, and thanks to what we've learned from this type of experience, of course, good things, bad things happen. So we are able to put together a comprehensive, solution, which takes the goods and maybe, obviously, make you be aware of the consequences of the bad things. And here is an example of a typical barge, yeah, which we have to, which we could put on the table, which is, a barge designed in a way that it's lean, with a bunker mast being in the middle to be able to serve port side, starboard, no ballast tanks. This has to be meaningful. Of course, have ballast for the initial trim thing, but there are some design choices like high maneuverability. People tend to design a barge as a ship, whereas it's gonna sail only 5% of her time, and most of the time we're gonna demand her to be maneuverable. So we're gonna more focus on the maneuverability than on the design, profiling, stuff like that, but just to be able to reach something lean and have this balance between CAPEX and OPEX. Shallow draft LNG carrier, which is another demand. Very low draft can be meaningful in some ways for isolated areas. And this is a seagoing bunker vessel, let's say sailing from Patras to Limassol could require, maybe a seagoing thing. So solutions are here, and we're trying to put something comprehensive. So this is on the onshore side. So this storage tank on the onshore side. So solutions are here, and the advantage of membrane is that if you have visibility issues and if you have space to occupy, there are a lot of solutions there, because it's integrated tanks. Because the hull or the concrete would be the base, and all the loads would be transmitted to that final structure. And there is no space in between, so that's maximizing the volumetric efficiency. So just pass by this, but you understand it. Membrane, it's high volumetric efficiency, and so we did this work with a very well-known container ship owner. Hopefully, you're gonna hear about them in the very next days. Well, okay, that's my conclusion. So I think the prerequisite for doing all this job as a designer standpoint is to understand the challenges, and I think that we pretty much did a good job in implementing our experience from the big scale and scaling them down and being careful about what it takes to do something very good. On the other side, there is still the collaboration thing. We initiated things, but of course, they said there is a shipyard who would like to go for membrane in Cyprus, and we're really ready to because the company is putting money and investing because the benefits we see them like down the stretch. So I mean that's a good talk, and we sit around the table. So just kind of call for action. I mean, if ever there is a need for it, either on the training side, shipyard readiness side, we can go for something. That's how we think we can be valuable to the Poseidon Metro. Thank you very much.
So our last but definitely not least speaker is Mr. Wim Gronendijk, President of Gas LNG Europe, who will address his presentation.
Ladies and gentlemen, I'm very happy to have been invited here to say a few words on the use of LNG as a fuel. And I will say these words on behalf of Gas LNG Europe, which is the association that represents all the large-scale terminals in Europe. And I'm very mindful that I'm actually doing this in borrowed time. It was supposed to be lunchtime already. And soon I think the growling of your stomachs will probably drown out any presentation. So I'll be as short as I can. So let's have a look at these terminals that we represent. Right. At last count, there were about 25 large-scale LNG regasification terminals dotted around Europe's shorelines. These are the big green symbols that you can see. There's also a couple under construction, which are shown in red. And there's many plans, glimmers in the eye, which are represented in blue, which may or may not happen. It's ripe and green all together. And together these regasification terminals actually represent quite a huge capacity. The combined regasification capacity of all these terminals is roughly half the total demand, gas demand of the European Union. Now, in recent years, these large-scale regas terminals have really picked up on the opportunity for small-scale LNG. And I'll start with truck loading. And I hope you can see it, but the dark green symbols represent terminals that have implemented some form of truck loading at their facilities, representing 19 EU seaports. And in fact, 2/3 of the terminals have actually done this. So they offer truck loading at their terminals. And we can see truck loading development in terms of number of trucks. More than 49,000 LNG trucks loaded per annum in 2016. And also we can see that over the past few years it has been going up. And we expect this trend to continue as more and more truck loading facilities are being added and more demand is being observed. Now, while there's a big environmental benefit in converting these trucks to run on LNG, I think there's an even bigger environmental benefit as a contribution to cleaning up the transport sector by getting ships to run on LNG. I think I don't need to go into this. I think it has been touched upon this morning already. There's huge benefits to be had from switching to LNG as a fuel. Now let's look at taking the LNG from the storage tanks at the LNG facilities and putting it into ships. There's many terminals that can actually do that around Europe. They're located near 14 EU seaports, and roughly half of the terminals actually have the facility to reload LNG from the storage tanks of the terminal into ships. And that reloading is really done for two reasons. Either it's reloading because you want to take the LNG, stick it back into one of these huge big LNG tankers and bring it to a higher priced market in the Far East or South America. So that's a form of reloading. But it's also, and that we can observe that increasingly, reloading that LNG into smaller vessels, either as a means of breaking bulk, so dividing the bigger volumes of these ships into smaller volumes and taking that to smaller markets, or it's loading into bunker vessels. And these small-scale ship loadings, typically up to 30,000 cubic meters. We've seen several small-scale ship loadings around Europe already. Zeebrugge, Gate Terminal, and in fact this year Klaipėda LNG in Lithuania has actually joined us in also being able to perform small ship loadings. This is combined with projects on bunkering, especially, for example, in Zeebrugge, bunker vessel in combination with NG, and in the Rotterdam harbour we have Shell as a launching customer, and who have recently, this week, in fact, commissioned the Cadissa bunkering vessel. I think it's also been mentioned, at this time we're still looking predominantly at ferries, container ships, and also very exciting, of course, cruise ships. This will be certainly the start of the market, but certainly not the end of it. Now let me give a few examples around the terminals in Europe. I'll start with the Polish terminal, which was commissioned, in fact, not more than a year ago, or just over a year ago, in fact. They started offering some basic large-scale regasification services. And what we noticed, and what they noticed, is that there is actually demand for these small-scale services. So they're adding lots of services to the terminal to provide LNG as a fuel for trucks, for ships. And these are their slides. They see a high perspectivity in this, and they have a good success, and they really see the market demand picking up. Second example, the Lithuanian terminal that I already mentioned, really built as a terminal for security of supply, large scale, but again, also they are working on providing LNG for truck loading and also for vessel bunkering. And my last example, of course, close to home for here, Revitusa terminal. Actually, these are the drawings from the project, actually constructing a truck loading station and a jetty for bunkering and feeder vessels. Lots of activity around the large-scale terminals for building infrastructure that allows LNG as a fuel to be taken up. As an association, we try to promote this, of course. Our members have to do it because they are the terminals, they are building the facilities. We are promoting that, and just to close, actually, I'd like to point you to some sources of information that we provide. We offer maps which contain a lot of information about current developments. One on the small-scale terminals, and perhaps more important for here, one for the small-scale terminals. And in fact, we're working on an update, and the next one will be available as of December. And in this small-scale map covers infrastructure for both sea transport, transport on inland waterways, and road transport. And it provides some information on each of the installations that are indicated on the map. So in the interest of time, I will stop here and look forward to the discussion. Thank you.
Thank you very much. I would like to thank all speakers for their presentations, and following the next step, which is the internal discussion of this panel, I would like to start with Mr. Popravko, who has an obligation and must go as well. So I will quickly ask you about the design phase of your new breed of vessels, and what is important to know is if you faced during the design any bottleneckings or any factors that they forced your designers or your engineers to radically change the design from the concept to the final design. And how about your coordination with the shipyard? I understand it should have been excellent, but I would like also to have a confirmation from your point as well.
I'm pleased to confirm that so far we have not had any big issues with the shipyard. In fact, we have our own in-house engineering center where we concentrated a group of experts in like naval architects, engineers, jointly working with the shipyard, we managed to adjust the design proposed by the shipyard to our needs. But you see, in fact, LNG fueled Aframax is a relatively simple vessel in comparison with, say, container vessels or cruise vessels. So we have two-cylinder shape LNG tanks installed on the deck. Total capacity like 3,000 cubic meters, which would allow vessel quite significant autonomy in terms of voyage duration. But so far things went quite smoothly, and we're pleased with about our cooperation with the main engine maker as well, so well-known name. Our relationships with HHI goes back in history like almost 30 years, so I think things went smoothly, quite smoothly.
Okay. Good. I'm asking this question because, okay, you have designed not a carrier but a user, an LNG user. So there are some things that possibly have alerted your approach, your design approach, and this is the reason why I raised this question. Although you are pretty right that the Aframax type is a more or less a simple type of vessel with no very complicated systems on board. Thank you very much. And now I would like to ask Mr. Polatos about the shipyards. And a very straightforward question. We realized from your presentation that you are looking support from the public and private sector, especially from financing your movements. On the other hand, I would like to hear your perspective on a very short way. If you are willing, as a private company, and not only you but also other shipyards, to invest by your own to start moving towards the LNG era, or if you will wait for the public sector to support you, or from private financial institutions.
I understand, Mr. Because you are a great engineer, but you put me on an economical financing corner here. Okay. Whatever I say can be used against me, of course. Yeah. All right. Yes. Aiming to attract the project, for sure. Both our company and for sure other even bigger shipyards, the traditional shipyards in Greece, should be in position to self-finance a certain phase of the project Of course, especially on whatever concern the pure yards productivity scope. We will not be in position to finance third parties' implementations into the project. For example, electronics, propulsion, etc. But the sector which is dealt by our human sources, which is steel structure, piping, etc. Yes, we can say up to 30%, 35% finance, expecting that thereafter, as the project will be developed and the client sees the progress, will be in position to support our initial step. Okay.
Good to hear that, because we all want to know if the shipyard sector is sitting and waiting, or he's active, or he will be active. Okay. Thank you. You are quite clear on that.
Yeah.
I would like to address a question to Ms. Kiratsoudi about the bunkering procedure that you have identified in your presentation. You have pointed out a very critical part of the whole bunkering procedure that has nothing to do with the safety, with the piping, with the engineering, with all these issues. You have focused on the cargo itself, on the LNG fluid. And my question to you is that since we are now moving slowly, but we are moving towards more stable bunkering procedures, the volumetric measure, which is now the common practice, is something bizarre to the community, to the bunkering community of the traditional oil. Although you mentioned that the mass flow meters are now introducing themselves as an example in Singapore, do you believe that this will be a necessary measure in order first to compromise the bunkering community that LNG is not different, no indifference regarding the measurement of the cargo, and second, to establish a very secure environment for cargo measurement on board vessels, because we have also to consider bunkering from vessel to vessel, not only from the terminal to the vessel. So my question is, in a short term, if you believe that the mass meter will create the stable environment that the bunkering market needs.
Well, if I judge from what is happening currently with the fuel oil that we all know and we use, at least the majority of the owners, I would say that the principle is yes. I mean, the principle that, for example, in Singapore they have been introduced mass flow meters is because of the malpractices. However, of course, it's not something that it has been set up with the logic that there will not be at all malpractices, because this is not something that it is happening. Currently, we know that some of the barges in Singapore has been they have removed their licenses, but the philosophy is a little bit different, because in the bunker fuel oil industry we want the mass flow meters because we want to avoid malpractices. Malpractices in the LNG is not something that it will happen. So it will just make the life of the LNG measurement easier. Just only this. No other problems with respect to cheating or.
So this is only from the technical point of view.
Yes.
To make the design easier and more adaptive.
Exactly,
okay.
Exactly. But it needs time, because imagine that this, for example, for Singapore took a lot of years this to be in place, and a lot of barges to be approved. It is a process that takes a lot of time. But for LNG, most probably will take. We have some room for further development.
Thank you very much.
Thank you very much.
Okay. LNG terminals, a very interesting field and a very precise link in the whole chain. Mr. Grondijk, you have mentioned to us good examples, good engineering in practice in some terminals in Northern Europe. I understood that the Klaipeda terminal is quite close to what we as Poseidon Med are looking up for Revithusa, not only for Poseidon but also for the Revithusa terminal itself for sure. So I would like to ask you if this experience, first of all, was a smooth one or a stormy one regarding the engineering point of view, and if you believe that the experience gained from this project is possible to be transferred to the upcoming project of Revithusa, which sounds to be kind of similar.
Typically, large-scale terminal projects require an investment of about 500 million to 1 billion euros. In comparison, these small-scale LNG projects, which are carried out at various terminals, are small indeed, but still they require tens of millions of euros for investment. And of course, there's always issues that you come across when you implement such projects. And there's always learning points at all the installations, not only at Klaipeda, but certainly also, for example, at Gate, at Zeebrugge, and other terminals. What makes it a little bit easier, and that's also the same for Revithusa, is that it's really an add-on to an existing terminal. So you get synergies, you get efficiency, and usually it's on site, which makes things a lot easier. But definitely there are always learning points for each and every one of these installations, and that is in fact a big part of what we do within Gas LNG Europe, is that we share these experiences amongst ourselves in order to be better, because there's no point in trying to keep this information for yourself, be monopolistic about it. We are trying to develop a market for LNG as a fuel here, so we actually benefit, all of us, if this spreads as rapidly as possible, if we get more and more and more projects, because that also gives confidence to the people who are going to use that LNG as a fuel, that the LNG infrastructure will be available. So now we focus on actually growing the cake, making it as big as possible, sharing the knowledge and the experience for doing that.
Perfect. Thank you very much. My last question is addressed to Mr. Diouf of GTT, and following your very interesting portfolio of products that you have identified to us through your presentation, I would like to ask you how GTT solutions and experience can be adapted to Poseidon Med to a system, and of course including vessels, shipyards, and possibly land terminals.
Yeah, in a variety of ways. The first one that we put on the public place is our expertise in LNG. What does it mean for real? Just really taking all the knowledge that we acquired from big scale and putting it on small scale. The second point to answer your question is the learning pool that we have acquired from building the barge in Jacksonville. I think we're doing on a continuous basis a return of experience, and we just realized that, okay, if we had to do it again, we would do it differently. And this is the gap between what you initially thought the perfect thing would be versus what things actually came across has been. And I think that there are a lot to share. How to accompany a shipyard, what are the challenges as far as the storage of the different pieces of equipment are concerned when you're a newcomer in this business. What is the level of initial collaboration, because people tend to forget the collaboration before getting into the project, and then they wish they could dig a little bit more at the conceptual phase. And those are kind of simple things that we could basically share in this pool, and the list goes on and on and on. We have a return of experience which is very long, and of course the technical expertise has been illustrated. I mean the consistency of our technology in this pool has been illustrated by the fact that due to some limitations, Corinthus Canal, weight limitation, and heavy seas, stability issues, for our technology, we've been able to leverage the volume up to 7,000, whereas for the competitors, it's just 5,000. But that's not the point here. Just not to highlight a difference with the competitor. The big thing is how can we initiate the LNG thing here, and my key word would be we cannot do it by ourselves, and that's all people coming up together, signing up some MOUs to make it happen, really inspiring themselves from what has been done in other places, because people tend to recreate the stone from scratch, whereas everything has been initiated somewhere else. So really getting those senses.
Good. Thank you very much. So we have now finalized our internal discussion. If you have any questions, you can address them to us. I don't know if somebody.
Blackus had a very interesting comment. It's not so much of a question, but perhaps one would like to comment on this thought. You said in Germany you met with colleagues and you sort of compared where we are now as
Can you please use your...
Oh, there we go. So we have phased out completely from coal. Do you or any of your colleagues share the view that in the future we will phase out completely in the marine industry from heavy fuel oils?
Sorry, if I understood well your point, you compare, I mentioned a crossroad where we are now towards a century back.
Yes,
okay.
Yes, that's right.
Okay. Whatever happened a century back, it's history and it's written down, and we know exactly how long it took for the implementation of the revolutionary, at that time, revolutionary diesel bunker. Okay, it took 15, maximum 20 years. We have a feeling, because the forthcoming investments from the shipyard, it's always on the discussed table among us, which are investing in order to stay on the LNG building business, how long it will take the eventual complete jump over from the dirty diesel to the clean LNG. I'm not hiding from you that the first feeling that we have as shipyards and makers of these floating projects is that it will not be quicker than 35 to 40 years. It will be it will take much longer than the century before. I don't know if this is a huge. This might be only a discussion agenda for the next.
No, you're
but I don't know
right.
what is your feeling. We have.
My feeling is the same. That if we go back and check the history of the now so-called experts in the LNG business, which are the Korean and Japanese shipyards.
Yeah, of course.
But if we go deeper in their history, we will see that the learning curve was around 35 years for them. So you are absolutely right. I believe your figure, to be honest.
Yeah, it's a feeling. It's not a figure.
Be a little bit,
it's not a figure. The pity is that
your feeling.
Yeah, the pity is that on a century back, Europe was the leading geographically location for this innovation, whereby, unfortunately, in our days, we are following. I'm not having anything against the colleagues in the Far East. Correctly, they saw something before us, or they had the ability to offer more competitive manpower. But the fact is that if we want to stay in that innovative perspective, we have to follow them, and we have to attract a certain portion of the production here into Greece. And that was immediately after I heard the presentation of our colleague here. I asked him, where do you build your nice design projects? And he's building in Far East.
Okay.
Okay.
Thank you very much. Another question from you? Then I think we are finished. I'd like to thank you all and thank our speakers for the interesting discussion we had. Thank you.
Okay, this is the moment I think everybody was waiting for. I think everybody's ready for their lunch. Let us, I know we're running a bit late, so let us be back by 3:30, please, to start the Synergy session in the afternoon. Thank you.
Because among the